Hi and welcome to Foundations 30 with Miss Verity. Today we're going to be looking at section 2.3. So Liam wants to buy a carving by an Inuit artist, Eli. He thinks it will cost $3,900 and it's considering these two credit options. So a line of credit, which has a limit of $10,000 and an interest rate of 2% compounded daily above the Bank of Canada prime rate. So right now, according when this textbook was written, it was 0.5%. I'm not entirely sure what it is right now. To be repaid in 16 monthly payments, or a bank loan of 4% compounded monthly to be repaid in a one-time payment at the end of the term. So a couple things. There's a difference between how we set up our NIPV-PMT with when it has monthly payments and when it is repaid in one payment. When it's repaid in one payment at the end, essentially what you're going to be looking for is your future value. All right, so Liam chose the bank loan when he found out that the interest amount would be the same if he would, Liam chose the bank loan when he found out that the interest amount would be the same as he would pay if he used the line of credit. So what is the term for Liam's bank loan? So how much interest would Liam pay if he used the line of credit? Because that's kind of our big thing, is the amount of interest is going to be equal between the two. So he is going to pay his in 16 monthly payments. He's paying it at 0.5% above prime. So 2% above prime. Prime is 0.5, so 2.5. Presently, he is going to owe $3,900. He's going to make payments of some type. We don't know what those payments are. He's going to pay off the loan. His payments are monthly, and his the interest is compounded daily. So we type that into our calculator. 16, 2.5, negative $3,900. PMTs, we don't know. Future value is going to be 0. 12 and 365. So solve for our payments. Our payment solving gives us $248.09. So then if we figure out what his total paid, well, he paid $248.09 and he did that 16 times. So 248.09 times 16 gives us $3,969.44. So that's what he paid in total. So then his interest is going to be his total paid, so $3,969.44 minus the loan he actually took out. So he took out $3,900. So in total, he's going to pay $69.44 in interest. So that's how much interest he's going to pay. We're not gonna do B, but we'll go on to C, which says what term for the bank loan will accumulate the same amount of interest as the line of credit. So N, we don't know what that is. Our interest rate for our bank was 4%. Presently, he has $3,900. Payment, he's not making any payments because he's going to do that one lump sum payment at the end. And if he's doing that payment at the end, we're looking for our future value, or we're considering our future value. But we know he's going to pay the exact same as he did with the line of credit. And so that is negative $3,969.44. With these two, it really doesn't matter which one is your negative in this case, as long as one of them is. Payments per year, compounds per year. Our payments per year doesn't really matter because he's doing a monthly payment, but we're going to make them the same as our compounding period. It is compounded monthly. So when we type those into our app, we're looking for N, 4% interest, negative or $3,900. Payments are 0. Future value is negative $3,969.44. Interest or payments per year is 12. Compounds per year is 12. So go up to our N and alpha solve. we get 5.3. So that means if it's looking for what term for the bank loan will accumulate the same amount of interest, well, that is a 6-month term. All right. Example 2, but before we do that, we are going to, we have to do attendance. So this is my way of seeing if you did attendance. Today's fun code word to put in your attendance is papaya. Anywho, so on to our second example. So Corey is buying furniture worth $2,348 on credit. He can make monthly payments of $125 and has 2 credit options. Which should he choose? Explain. So the furniture store credit card, which is offering a $40 rebate off the purchase price and an interest rate of 19.7% compounded daily. That is what a credit card rate is. I actually looked at mine this morning. Mine is 19.9. Which is very high, which is why you never want credit card debt. Or a new bank credit card, which has an interest rate of 21.4% compounded daily, but no interest for the first year. Okay, so let's start with A. So a furniture store, we don't know how long it's going to take him to pay these off. We kind of want to figure that out. So it is offering a 19.7% interest rate. Presently, he is taking it out for $2,348, so he owes them $2,000. Ooh, no, he doesn't owe them that much. Well, we can write it like this. You could either do the math first, which is going to be our $2,348 minus the $40 rebate. A $40 rebate is basically just money off. You could also get your calculator to do that in this section. Just make sure you know how to deal with the negatives, because you'd want the negative 2,348 plus $40 if that's how you're typing it in. You could go plus $40. You could have the negative and then brackets with the 2,348, subtract. I don't know, math beforehand is just as easy. And those of you who are using the app, which all of you are right now, it doesn't do that. Payments. He can afford payments of $125. He is going to pay it off. It looks like he is making monthly payments and the credit card is compounded daily. So what is our N? So looking for N, 19.7, negative 2,308, payments of $125. Future value is going to owe nothing. And interest is compounded daily. So that gives us an N of 22.22. So if we're looking at his total paid, he is paying $125 and he's doing it for 22.22 months. The reason we use the decimal is because for those 22 months, he's going to make that full $125 payment. For that last part of a month, or the 0.22 of a month, that's going to be under $125, whatever the remainder is. So this gives us a total of $2,777.50. Okay, on to scenario 2. So he's got a new bank credit card, which has an interest rate of 21.4% compounded daily, but no interest for the first year. So that no interest for the first year is kind of what's going to spice up our questions. So N, we don't know. We're going to look for how long is he going to pay. The interest rate on this credit card is a whopping 21.4%. So then we want to figure out our present value. So he is making payments for the first year, but we don't know what those are. So I'm going to do math on the side, because for those of you who are on the app, you're going to have to do it on the side. So he currently owes $2,348, but he is going to make payments for a year of $125. So that is going to give us $848. So he only has to pay interest on $848. So then he's going to make payments of $125. He's going to pay it off, payments monthly, and his interest rate is compounded daily. So 21.4 4, negative 848, 125, 0, 12, and 365. If we solve for our n, we get 7.30. So our total paid, well, in that first year, he paid 12 times his 125, plus now he's paying the 125 for 7.30 months. So the 12, this is our first year, and then this is the payments with interest after the first year. Okay, so that is going to be 12 times 125 plus 125 times 7.3, which gives us $2,412.50. So if we're looking to answer the question, it's which should he choose and why? Well, if we're looking for the why, it's going to be, he's going to choose option B. He saves, well, if he's saving, it's that 2777.5 minus our amount that we have paid in B. So he saves $365 with option B. Okay, so Logan bought a new sofa for $1,289.47. He paid for the sofa with his credit card at 18.6% interest, compounded daily. If Logan repays the loan in 1 year with 12 monthly payments, how much will his payments be? Okay, so he is going to do 12 monthly payments. He's got an interest rate of 18.6. Presently, he owes $1,289.47. We don't know what the payments are. He's going to pay it off, and he's got monthly payments compounded daily. Typing that into our app or our calculator, we have, 12, 18.6, negative 1289.47. We don't know payments. Future value is 0, and 12 and 365. So solve, and we get 118.67. So that's how much his payments are. So when Logan checked his mail, he had an offer for a new bank credit card with a $40 rebate and an interest rate of 17.5 compounded daily. If he'd used the new credit card instead, what would his payments have been, and how much would he have saved? So he is going to still pay for 12 months. This interest rate is 17.5. Presently, he owes, or it's going to be the negative of our 1289.47 minus the $40 rebate. We don't know what our payments are. Paying it off, 12 and 365. So interest rate is 17.5. The negative version of 12.89.47 minus 40. We don't know payments, future value, 12,365. So alpha solve. We get payments of $114.33. So that's how much his payments would have been. How much would he have saved? Well, in option A, he had payments of $118.67 for 12 months. So $118.67 for 12 months is, he paid $1,424.04. Option B, he had $114.33 for 12 months. So $114.33 for 12 months is $1,371.96. So the difference between those two is $52.08.